Hello, and today we're going to be having a look at creating a hex-based grid as a foundation for any kind of hex-based tile game that you're looking to make. Hopefully this will allow you to create something similar to, this is a game that I made recently for a game jam that's based on the same kind of basics that we're going over today, where you can just build up a world made out of these hex tiles, and then you can customize each tile, and yeah, you can be creative with how you want to have your world generated and the likes. But yeah, we're going to be doing it from scratch, a new Unreal Engine project. So let's get started. So I'm using version 4.26. It should be fine in any version, to be honest. We're not using anything too fancy in here. And if we just go ahead and start a new game, you can start with a blank project, and we're going to go into C++. And I'm just going to give it a meaningful name. So I'm just going to call this Hex Tutorial for now. Press create project. It should take a little bit of time just to get started, and it should hopefully open Visual Studio for us, and then it will also open up the editor for us as well. So one thing I will get up on screen ready is a resource that's super useful, that is going to be good if you're going to carry on to make a hex-based game after this kind of introduction. Then this website is something that really goes in detail over all of the kind of maths or the kind of rules you use while using a hex-based grid. And so yeah, it is redblobgames.com/grids/hexagons. But yeah, I'll refer to it once or twice during this. But I just wanted to make sure that you people are aware of this, and you can open it alongside if you want to reference it yourselves. Okay, so it is generating the game code. It's going to take a little bit of time now, but what we're hopefully going to get by the end of today's video is you're going to be able to have a scene in Unreal Engine where you can add in what we're going to call a hex tile manager. You can tell it how many or how wide and how tall you want your hex grid to be. And then when you start the game, it will create that hex grid for you, and then you'd be able to build on top of that framework. So we have the editor as opened, and we also have our Visual Studio opened here. So let me just get this open up for us. Okay, lovely. Okay, we don't need to specifically do any code right now because we need to make some classes first. First thing we're going to go ahead and do then is we're going to create a couple of folders just to keep our working a little bit tidy. So first off, going to open up this the file view. I prefer working that way, and then we're going to go ahead and just make one folder for the levels because we're going to make a new level, and then we can probably make one for our blueprints that we're going to create during this as well. So in the levels folder, we're going to first add something. So we're just going to go file, new level. In here, we'll go with the default one, and then Control S here to save. I'm going to go into my levels folder, and we're just going to call this our Hex Grid level. No problem. Okay, so this is what we've got at the moment. Very little in it, but it doesn't matter for now. The one thing I'm going to do quickly before we get into anything is all these kind of base things that are in here by default. I'm just going to shift them along a little bit, just so that they don't clash in the way a little bit later. So I'm just going to select the light source, atmospheric fog, sky sphere, skylight, and the sky reflection capture, and we're just going to chuck them in their own little folder. I'll just call these the environmental things. And I'm just going to whack them all on the same location as 0, 0, 0. You don't have to do this. I'm just doing it to try and make it a little tidier later when I'm explaining. So just put them as 0, 0, 0, and then we can just move them away a little bit. That's no problem. Yeah, so there we go. We've chucked them at, let's chuck them at 1000. That should be fine. Okay, and then we've got our player start as well. In here, that's fine, and we've got some floor. We'll probably delete that in a bit, but that's no problem. So yeah, let's get started. Let's make two classes then. I'll just press Control S to save my map, and then we're going to go into our blueprints folder. Actually, no, we're going to create the classes first. So we're going to go, you can go into your CPP classes down here, and right-click and create a class. You can do it from File, Create Class as well, if you want new CPP class. So first off, we're going to create a new one. These are both going to derive from Actor, the two classes we're making. So the first one, click Actor, and then give it a name. We're going to call this our Hex Grid Manager. I'm going to create the class. It's going to take a little bit of time, and it'll probably open it in Visual Studio as well. So this is going to be our thing that manages the spawning of all of your hex tiles and manages the logic that says how many rows and columns and how far they should be spaced apart and the likes. So it's not going to have a physical representation itself, but it's going to be the actor that spawns in all of the tiles that we're making, the hex tiles. So there we go. We've got this class made. I'm just going to go ahead and create one more quickly. So the second one we want to make is going to be, again, deriving from actor, and this is going to be our hex tile. So let's go ahead and create the class there. And again, it'll take a little bit of time and then it'll open up in Visual Studio for us. So we'll get started with this hex tile because this is going to be essentially the foundation of what this is based on, right? It's a tile-based game. Each of them are going to be hexagonal, and so we need to create what a base tile is. I'm just going to click reload all here. Okay, brilliant. So now that we've created those, I'm actually going to go ahead and close the editor because we'll relaunch it once we've done a bit of code now. So I'm going to close the editor down. And then we can get started with our code. So first things first, we don't actually need, I'm in hex tile here. I'm going to just, I'm using Visual Assist. So if my code looks a little bit different to yours, don't worry about it. But I don't want to go over the nuances of Visual Assist now. But it will allow me to use some shortcuts that maybe you can't, but you should be able to get around it yourselves. It's not a problem. So we want to go into the CPP of this. So I'm just going to go ahead and open that up. So I'm in the hex tile CPP now. And what we want to do first is get rid of this tick and begin plate. We don't need to use those. Okay, so we're fine just to have a constructor in here. I'm going to go into my header and I'm also going to remove those because we don't need those. Okay, so what do we need? So first off, I'm going to create a couple of members. And then I'm also going to create an enum to represent a type of tile. So let's say that this is going to be a world we're building. We might have some grass tiles, some mountain tiles, some water tiles and the likes. So let's go ahead and create an enum for that first. So I'm in the header for hex tile and I'm just going to declare an enum in here. So let's make a uenum, enum class hex tile type. So the type of tile that we're going to be using. And then we're going to go and define the different ones now. So first off, I like to do invalid as the first one, just so you don't accidentally, if you haven't selected a value for this wherever you use it. And then I'm going to do grass and water for now. You could have more, it's up to you, but we'll just start with those. And then I tend to finish off my enums with a max value as well. Which won't show up in editor if you add that bit of code. Okay, so we've added our enum. So we're going to go ahead then and set up a member which will hold that tile type. So I tend to do all my members at the top and then all of my functions at the bottom. So that's why I'm just going to make a new section up here. So I'm going to make a protected section here for my protected members. And this one is going to be a U property, because we want to expose this out to editor. We're going to make it so it's edit defaults only. We're going to make it blueprint read write. I don't actually, you probably read would be plenty, but let's just do read write to be safe. And then we're going to go category. I'm just going to give it a category of tile. Okay, so then I'm going to give it the actual type, which is that enum that we've just created up top, and then I'm going to give it its name, which is going to be tile type. Okay, so this means for every tile that we're going to create, we can give it a type. So it can be a grass tile, or it could be a water tile, or however different ones you want. And the idea is we'd make a blueprint of the different types, and then when we spawn them in, we can choose from those different blueprints which ones we want to put in. So we're also going to do, we need a physical representation for this tile now. So we've got a data representation of what it is, but we now want to go ahead and do make a static mesh so we can physically see the tile, right? So that's the step that we're going to take next. So we're going to use a use static mesh component. I'm happy for this to be the same U property details for now. It's not massively important for the purpose of today. And then we're going to just call this tile mesh. Okay, so we've got those. That has been set up, and I guess for now, let's have a look at what that looks like. So we can go ahead. Oh, actually, with a thought, we probably need to set it up in the CPP as well, right? So we can actually spawn this. Yeah, let's do that before we launch the editor. So yeah, we don't need this tick, so we can get rid of this. I mean, or you can even set it to false, but I think it's false by default, right? So you can just get rid of that. So the two things I'm going to do, I could just spawn the tile mesh. So let's go tile mesh equals create default subobject. And then this is going to be of type U static mesh component. And we'll just give this a name, which is going to be our tile mesh for now. Okay, so we could just do that. But what I like to do is, because we might want to move, if you do this, the tile mesh will become your root component of your actor. And we may want to move this mesh around. And so I'm going to give it a separate root component instead. So the root component already exists as a part of actor. And we're just going to create a using component for this, just so that we have something that is our root component that isn't our mesh. Okay, so this will be a using component, and then we'll give this a name like we have, root comp. Okay, good. And then the final thing, if we're using a different root component, we then need to set up the attachment. So we'll do tile mesh, and then we're going to go to set up attachment, and then we can put in the root component. So that'll mean that it'll be attached to it. Excellent. Okay, so that's pretty much all we need to do here. We need to do some includes as well. I've got some fancy shortcuts for this. Oh, if Visual Assist was working, I could. But okay, yeah, you can just manually do the includes yourself then. My Visual Assist isn't working after all that talk earlier. So we want to go ahead and include it's in the components folder, because these are based on real things. Scene component.h, that's where that one lives. And then we're going to go ahead and do components. And this is going to be for our static mesh component. .h. Okay, so they're declared there. Let's make sure, are we in this header I've just jumped to, we're probably going to want to forward declare this as well. Again, is this, yeah, it's not working for me. So I'll just do my forward declare separately. So I'm going to go ahead here and just say there will be a class defined as a use static mesh component, like so. All right, that should do it for this. So we're going to just do a quick compile, make sure that I haven't made any mistakes, which is perfectly feasible. I may have. Yeah, there we have. Oh yeah, we missed the pointer. Yeah, there we go. Okay, so hopefully this time I'm going to press F5, because hopefully that's the only thing that was wrong there. F5 will launch the Unreal Editor for us as well. Yeah, there we go. So it's compiled nicely and it's just launching the editor for us now. So what we're going to have now is we can create a blueprint of that actor. But we don't have a mesh for it. So we're going to quickly make a mesh for it as well. Let's go ahead and jump into that level we had. Let's first go into our blueprints folder. We're going to make a new blueprint based on that class that we've just written, right? So blueprint, instead of doing it from one of the base ones, we're going to go ahead and look for our hex tile that we've just made. So we've gone into hex tile, select, call this BP underscore hex tile. We can jump into that then. Drag this window up here. And yeah, at the moment, you can see there's the root component that I made earlier. And then we've got our hex tile mesh. But at the moment, you can see we can't actually see anything here because we don't have a mesh associated with it. So we need to go ahead and make a hex tile. And I'll just do it really quickly in Blender. If you haven't got Blender, it's free. So just download latest version of Blender and you can do exactly what I'm doing. So let me just open Blender. I'll move it across then so you guys can see. Okay, so you can just press escape on that. We need to close that. Delete everything that's in your scene. So we don't need the camera, cube, or the light. And then all we're going to do is make a new thing. We barely have to use Blender at all. So Shift and A brings up the add menu. In Mesh, you can go down to cylinder. And then on this little box down here, if you press the little arrow, it'll open up properly. And we want to say how many vertices is going to be that make up this cylinder. If you think a hexagon, if a 3D hexagon at least here is going to be basically a six-sided cylinder. So if we give this 6 instead here, you'll see that it changes to look more like a hexagon. You can use your middle mouse to move around to check the shape of it if you want. I'm happy with it having a radius of 1. That's the kind of size of it. And then I'm going to go ahead and just set this to 0.25, just so it's a little, it's got a bit of chunk to it, but it does look more like a tile now. That's fine for me. Okay, so I can now go to File. We can now go to Export, and I'm going to do it as an FBX. And then I'm going to put it in the location of my project. So I'm just going to go to my specific location where I've got my project set up. You'd have to go obviously to wherever your project is set up. So mine was Hex Tutorial, into the content folder, and then I'm just going to save it here. So let's give it a name, and this will be our hex tile, for example. So let's press export. And a nice thing about Unreal is Unreal will detect, oh, you've added a file into your content folder. Do you want to import it as an asset? Great. So let's press import. We don't really need to change anything in here. So let's press import. And now we will have an asset. Let's go and have a look. So if I go to content browser, and just save that blueprint, and we go into the main folder, we now have a hex tile here. Excellent. I could drag one of these in. That's just the mesh of it though, remember? So we're not going to drag one in, but what it does mean is now that I can go ahead and I can set the mesh to be my hex tile here. You can type it in if it doesn't show up there. So there we go. We now have a tile asset, which is good. So if I go into my blueprints, we now have a BP hex tile. I can drag one of those in instead, and there we go. We've got our first hex tile. We can make Control W. We can make multiple of them if we want. Now, at the moment, you notice they don't have a material. So I think a sensible thing for us here is to probably make some materials. I remember when I was starting off, I didn't actually have any knowledge on materials, and it always made me a little bit frustrated that it seems something so simple. I just wanted to give these colors, you know. So let's go ahead and make something simple just so we can assign colors to our tile, shall we? So we're going to make a new folder in here. We'll call this materials. First off, we're going to make like a master material. It's nothing too complicated here. It just makes making different colors easier as we go on. So we're just going to call this m_color base. We're going to go into this. And effectively, we want to make like children of this material, but we don't have to come into this graph every time to set up the colors and any, maybe we want to change the metallic, specular, or roughness of it as well. 3 common things that you might want to change about your material. So what we're going to do is just expose these out as parameters instead, so that our child classes of this material can just have easy access to them. So let's go ahead and do that for all of these. I'm just going to drag them across so it's easy to see. Right click parameter. For all of these first 4, and then I'm going to set some default values for them. So for the base color, let's just say it's something obvious so we know if we haven't set the color. So it'll be nice and pink to begin with, and then metallic over down on the bottom left is here. We'll set the default values for it. So I'm okay with metallic staying as 0, specular can stay as 0, and roughness we'll put as like 0.5 for now. Let's just have that as our kind of base material. So we save that, and now we can make material instances of that. That's the kind of sub or child classes of this material that I was mentioning earlier. So I can close that down. And if you right click on your material, create material instance, we're going to call this MI for material instance. And then I'm just going to call this color green, for example. All right, because we're going to have a grass tile, right? So if I go into this, now instead of having to go into the graph, I can just tick the base color box. I can say, right, I want this to be a shade of green. So you can do whatever color you want. Let's go for that. Okay, so we've got our green color here. Let's go ahead and save it. And let's make one more color, shall we? So I'm Control W on this to duplicate it. I think instead of green, this is going to just be called blue. And this time we will change it to be blue for our water tile. So that looks fine to me. Now what I might want to do on this as well is, because it's water, we might want to say, okay, actually you have a little bit of, instead of having 0 specular, you might want to take this up a little bit. So let's put this as 0.5. So there you go, it has a little bit of shine on it there. And we might make it a little bit metallic as well, just to make it look a little bit more like a shiny surface. But that'll do for now. So we've got those two materials now that we can use. So this tile that we've made, this is going to be our base tile that we can do any logic in here that you might want to do in the future. So I'm just going to assign this not a grass or water. I'm just going to give this the base color that I made earlier, this pink color, because we're not going to be adding this tile into the world. We're going to make subclasses of it. So we're going to go ahead and do that now. So you can see these two here. Let's get rid of those. Let's go back to our blueprints folder. And in here, we're going to make a child blueprint class. So we're going to make one of them, which is going to be hex tile. And instead of calling it hex tile underscore child class, we're going to call it underscore grass. Let's go into this. And all I need to change in here then. So first off, we're going to go and have a look at the mesh. We're going to change this to be the green that we just made, like so. And the second thing we want to change about it is, if you remember, we had that tile type, didn't we, that we declared in the code earlier. So remember this tile type, and we exposed it out here? Yeah, so we're going to set that to be the grass one that we set up earlier. So let's go ahead and do that. So this is grass, compile and save that. And then let's quickly do the water one as well. It's not going to take any time. Control W to duplicate that. We'll call this water. Go into this one. We need to change this to be water. And then we're going to go into the full blueprint editor. So I can just select the tile mesh. And we're going to select the blue color for that one. Excellent. So that gives us now two different tiles that we can use. Obviously, you can think about how you want to do this yourselves, but I just wanted to give a very simple example to begin with. So now that we've got these, we should be able to just add them into the world and start thinking about hex layouts a little bit. So let's add in a green one. Let's add in a blue one. So we've got two tiles. And we need to try and think about how we're going to kind of lay things out. Because tiles are easy if you're using squares, right? Because it's the same distance horizontally. Each tile is separated by the same distance horizontally as it is vertically. However, with a hex grid, remember the website I showed you earlier, it has a bunch of examples that you can look at. You can see there's not quite set up that way there. And there's a bunch of different ways that you can set up your hex grids, but ours is going to be, the pointy side of our hex is going to be pointing up. And every second row is going to be like shifted in 50%. So you can see we have, this is our first column, this is our second column, and then the rows are quite standard straight across. Okay, but because it has this slight different, non-kind of uniform pattern, because it's different every odd row, we are going to go ahead and kind of think about the locational differences between these tiles now. So let's go back and have a little look at what we've got. So let's put the first tile at 0, 0 to begin with. Put that at 0, 0, 0. And we'll put this one at 0, 0, 0 as well, and we'll get moving it. I'm just going to move to a top-down perspective for a sec to make it a little easier to see what we're working with. So they're both on top of each other at the moment. We've got hex tile grass, hex tile water here. So I'm going to just move one of these. So remember, X is your like left to right, and then you've got your Y as your up and down in this view. So if you remember, when we made this in Blender, we gave it a size of 1. I can close this now. We don't need Blender open anymore. You can save it if you wish. I'm not going to. We've exported the FBX, and that's what we needed. So we don't need a Blender file for it. If you're new to Blender, that's all that was asking. So yeah, we have a size of 1. And what that means is the full height of it is going to be twice that amount. So this here, if I right click, you can see a little ruler comes up, a middle click, sorry. And you can see that the height of our tile is 200. And we can verify this by some of the maths set up here. You can see here that it'll say, so the height of a tile is 2 times the size. Okay, cool. So the size was 100 earlier, and it was 1, but that is in 1 meter. And in Unreal, we work in centimeters. So 1 in Blender equals 100 in Unreal. So that's why we've got a size of 200 here. Okay, so yeah, this is telling us that our hexagon, the height will be 2 times whatever the size was. And then it says the width is slightly different. You notice it's not the same shape. It's not the same width as it is height. It's a little bit narrower. And the rule here is the square root of 3 times size. Like, you don't have to understand this. If square root means nothing to you, don't worry about it. It's just there is some maths behind this rather than us putting in magic numbers. I wanted you to kind of understand why we're putting in certain numbers here. So what that means then, if we go back to Unreal, is if I wanted to move, remember I've got 2 tiles on top of each other here. If I go into the location here and I say, right, I'm going to move on the green axis, the y-axis here, we know that this is 200 tall. So if I add 200 here, we can see that 1 perfectly lines up below it. Let's change it to lit as well so the colors are a bit clearer for you to see. Okay, so you can see that we've moved it bang on to the bottom of it. That's nice. But that's the thing with hexagonal tile grids, is the layout of it is actually going to be different. They're not going to be top to bottom like that. If you remember, the top of this one, or the bottom of this one, connects with the corner of the one below it, which is shifted across a little bit, right? Okay. So, but we know that the height of it is that. And if we wanted to know the width of it, let's move this one back up to 0. So it said, if you remember earlier, let's get the calculator open. Okay, I've just switched to scientific mode in here, if yours looks different to mine. But it said the square root of 3, right? So if we go 3 and we press the square root button here, okay, that is the square root of 3. And then we want to times it by the size, which was 100, if you remember. So I'm just going to do times 100. That should be how wide our tile is. So let's go ahead and check that. We might have some rounding issues, or where it gets truncated somewhat, but it should pretty much be accurate here, right? So let's take that number and let's put this in the x-axis to move it across. So if I put that in there, I've just Control-V to paste in. You can see now we've perfectly moved to the side. So there is like maths behind how like wide it is, and you can use that as part of your calculations to build up this hex grid. So that's how we would set that up. Let's try and think. So moving across, the width of it is going to be just this, right? If we wanted to set up tiles that are exactly right next to each other. So if I wanted to add another one onto this, I would just go ahead and let's change this back to 0. And then I'm just pasting in the number. I can put times 2, and that'll move it across a little bit. Oh, I'm not sure if I made a mistake with that value in there. Let me go ahead and copy it from here again. Get that out of the way. Let's put that value in. Yeah, that moves it bang on top of it. If we times that by 2 now, there you go. That's what I was trying to do there. So it just moves it across. So you can see we can just times by that amount to kind of fill across in that direction. So let's think about that next row then. So how far down do we need to go in order to do this second row? Let's look at the diagram again. To do this second row here. Okay, so there is information. All the stuff I'm telling you now is pretty much found in here, right? So you can find out this information here, for example. So the horizontal distance between adjacent hexagons, horizontal, this side to side kind of distance is going to be the width, which was that weird number, that number that we put in earlier. Great. So the vertical distance is going to be the height times 3/4, which is 75% of the height, right? So the height, if we remember, was 200 earlier. So if we type in 200 and we times it by 0.75, that will give us 150. So we know now that it's going to be 150 units down in order to go 1 row below. So let's go ahead and do that. I'm going to just duplicate this grass tile. We'll reset it back to 0, 0, and then I'm going to add to it 150. And there we go. It's moved it down. And you don't know if it's in the right spot yet, but if we move it across, you can see it does just fit. It is the right height for it. Now it's snapping a bit on when I'm moving it across, so it doesn't look like it's fitting in perfectly, but you can see there it would fit in lovely there. Okay, so we've got the height. Now we need to work out this gap. So that's the thing with these hex grids. You need to add an offset for every other row. So it's going to be the same distance between each one. So we're still going to use that square root of 3 times 100 between each tile on each row. But depending on if the row is odd or even, or every other row, if that's easier to think of, we want to add an offset. And the offset, if you think about it, is just half of one of these hexagons. And we know the width, well, we worked it out earlier, right? I can click on this, we can just borrow the value from in here. So this was our square root of 3, right? So if I just go to, we'll do it again, square root of 3, and then we times it by 100, gave us that value, right? So if we copy that, what we want to do is basically just half that. So I can times it by 0.5 or divide by 2, whatever I prefer. And there we go, we got half of that value now. So I can go ahead and we can write that in the X here to shift it across. What we should find is now it falls right into the right position. So we're doing it exactly snug where they're right next to one another. And if we change back into perspective view, it may not look exactly the best. Sometimes it's nice to actually see the tiles. So if you want, you could always add a little bit of gap between them. But the nice thing is what we're going to do, we're not going to manually build this up. Our Hex Tile Manager class that we started making earlier, we're now going to work on making that automatically spawn these with the right distances in between. But the important thing is here, now we understand that there's different bits of maths that we need to understand. We need to understand how wide a tile is, how tall a tile is. We need to know the horizontal gap between tiles when we're spawning them. So we know that there's a tile width between each one of these. We also need to know the vertical gap, which was 75% of the height. So that was 150 units down. And then we need to know for every odd row, the placement of it is going to be offset in the right direction by half of the tile width, which was around 86.5-ish in the end. So now that we know that, that'll help us understand what we're going to be doing in this next step. So let's get to it then. Let's make the thing that's going to spawn this automatically for us. I'm just going to go ahead and select all of these. We won't delete them. We'll just move them out the way somewhat, just so we can refer to them later if we need to. Okay, back to the code then. So earlier we made a hex tile, but we also made a hex grid manager, and at the moment we're going to have just 2 empty files that we haven't done. So I'm in the CPP of it here, and then I've got the header of it here. Now we don't need the tick in this one, so let's go ahead and delete that first before we get started. So I've deleted it from the header there, and I'm going to go ahead and delete it from the CPP, and I'm going to tell it that it doesn't need to tick as well for that reason. Great, okay, good start. So what we're going to do first is we need to create a 2-dimensional array. Because we're working in a grid, you'd do this if you're doing a square grid as well, is generally the way that people tend to represent it is a 2D array. So that means that you'll be able to access it by doing like my 2D array, whatever you call it, and then you can give it your X coordinate and you can give it your Y coordinate, and that'll allow you to reference things by their kind of XY coordinates, which is a bit more natural to do. And it makes it quicker to access what you want to do when you know the exact location of the tile or the coordinate of the tile. You can just access it in the array in this easy and kind of nice to read way. So we're going to make a 2D array for this. We're also going to set up some variables that we can set up on this manager in order to denote how wide and how tall we want our grid to be. So let's get started with that. Like I said, I like to do my member variables in a separate section. So for that reason, I'm just going to do a new kind of protected area up here. And then we're going to get started with writing some of these out. So first off, let's do the easy stuff. So U properties, these are going to be edit anywheres. So if you don't know the difference between edit anywhere and edit defaults only that we did last time, edit anywhere means once we've added the blueprint into a level, we can change the value as well. And we want that for this so we can tweak and play around with it in the world. I'm just going to give this a category of hex grid. Okay, And in here, this is just going to be an int32, and it's going to be our grid width. So how many tiles wide we want, right? This isn't like a size thing. This is how many individual tiles do you want. And we're going to do the exact same thing for the height as well. So let's just copy paste that in. And this is going to be called grid height. To be honest, I might actually put these in a nicer setup thing as well, just as this a nicer practice in my opinion. So this will be in a subsection of grid height, of hex grid, which is going to be called our layout, let's say. Okay, so let me just copy that into both of these. Okay, so we got our grid width, and we got our grid height. I'm also going to add in here that two-dimensional array I said. So it's a T array, and inside that T array is another T array. And it's going to be holding pointers to the tiles that we've made. And if you remember, our tile class is a hex tile. So we add the pointer. There we go. Bit of a mess of symbols, but that's what you get with a 2D array. Okay, and we're going to call this our hex grid 2D array. Okay, so that's where we've got started with. Well, we're going to now go into the CPP and see what we can do with this starting point. So in our begin play, we're going to go ahead and we're going to essentially do a little bit of initialization of the 2D array, just so we can safely access things without getting arrays out of bound issues. And then we're going to start iterating over our array in order to spawning the actors. So let's do that. If you've ever done 2D arrays, you'll be familiar with the pattern. You just do like a for loop within a for loop. But so the first thing we're going to do is to initialize the values of 0 so we can safely access the indexes in our 2D array. So within my hex grid 2D array, I'm just going to call a function called setNum0'd. And this allows you to just initialize them as 0 effectively. So first off, we want to do our width. We're going to set, because you think we've got an array of an array. So we want to go across all of our arrays and set them to zeros first. And then what we want to do is we want to iterate over all of those newly zeroed ones. And we want to set each subarray's value to be 0 equal to the grid height as well. So let me write it. It'll make a little more sense as I write it. So we're just doing a normal for loop here. We're going to go over the array.num that we've just set here. So this 2D array didn't have an amount of elements, right? Until we did this. This is the bit that says, right, you were going to have 5 things across. And now what we need to do is say for each one of those 5 things, you're going to have 5 things down as well. So that's all we're doing, as much as it may look a little bit confusing. Okay, so we'll do that. And then I may have put an extra bracket in here. That was my mistake. Okay, and now what we do is we access the ith element of this, and we're going to do the exact same code as we did above, setNum0'd. But this time, instead of doing grid width, we're going to do grid height. So this allows us to be able to set different widths and heights. And this is just going to create our kind of like empty structure for us. Okay, after that, that's the only bit that's a little bit weird, if I'm honest with you, in this start, if you're not used to doing a 2D array in Unreal. So the next thing we want to do is to create the grid. So we're going to go ahead and create this loop. It's going to be a 2D a loop within a loop. So let's do our first one, which is going to be very similar to what we wrote above, but we're going to use more meaningful names here. We're going to have our y first. We're going to set that as 0. It's going to go while y is less than our grid height. And we want to go ahead and do ++ y. You can do y++ if you want it. It really doesn't matter. I've just been, it's an small optimization that I've kind of just been ingrained in me at the moment. And then we are going to go and do the exact same thing, but this time we're going to do it with x and the grid width instead. So let's just drop this in. We can go ahead and put x in. put X in here, and plus plus. There we go. And changes the grid width, don't forget that. Okay, good. And let's set up the braces for that as well. Now, okay, so this is effectively going to go through each row first. The inner part of this is going to be the thing that's iterating over first. And then for each one of these rows, it's then going to go through the columns. So let's have a look what we need to calculate inside of here. So first off, we want to know, if you remember earlier, I referred to the fact that every odd row is kind of different here. So we're going to do a little bit of calculation here to work out, are we on an odd row or not? So let's just call this odd row. So are we on an odd row? And that is going to be based on the Y, which is the kind of the going down direction, right? And you can just do a modulus 2 on this. This is a quick way to know whether or not, like the remainder of, if you divide by 2, if it's 1, then you've got an odd number. Okay, so this will just tell you, are you on an odd row? The next thing we're going to do is we need to work out, if we are on an odd row, then what is our kind of position going to be when we're spawning this new tile. So if you think we're going, if we had a 5 by 5 at the moment, we're in position 0, 0. So we need to spawn in a tile there. Then when we go to 0, 1 next, or 1, 0, we then need to go ahead and spawn in a new tile there as well, but the position needs to be shifted across. So that's what we're calculating here. So we can think about it as, okay, our X position is going to be, for the first row, let's just do this first. Our first is going to be equal to whatever our X is at the moment, right? And then we want to times that by our offset that we were discussing earlier. Do you remember we were looking at the tiles and saying how far across from one another they need to be? So if you remember, the difference between them was that massive, that weird 173 dot whatever number, right? So we need to kind of write that in, but we'll do it as a member instead, right? So we can tweak this and play around with it in editor. So I am going to probably create something, we'll call it a tile horizontal offset, let's call it. I don't know if offset is the right word, but we'll go with it for now. So yeah, let's go ahead and make this so it actually makes a little bit of sense, shall we? So underneath these, it's going to be kind of similar to these. So let's just copy that in for now. This is going to be based on the layout still, so we can keep that first line up there. But this is going to be a float this time instead. And I called it, oh, I just accidentally deleted my, my copy paste. So let's go back, copy this again. And okay, cool. So we have our tile horizontal offset. Now we're also going to have, we want to do the vertical offset as well. We'll need that. So we might as well copy this and do that while we're here. So tile vertical offset. Okay. Cool. So now that we've got those, so our X position of where we're going to spawn this is going to be based on whatever iteration of X we're on, times by how far apart they need to be across. Then the next one, the next thing that we need to sort here is just setting up our Y position then, right? So it'd be very similar. We'll do const float Y pos, and this is going to be equal to Y times, no surprises here, our tile vertical offset instead. Now, the thing we haven't considered yet is we need to consider the slight offset that we have on every odd row. Do you remember this thing? Yeah, how this is like half a tile width across? Yes. Okay, so what we're going to go ahead and do, we can add an extra member, and we could do the maths in here, but for now I'm just going to expose it out as a member so we don't have to play around with code. We can just tweak in editor later. So yeah, I'm going to go and toss it in here underneath this, and we'll give it a slightly different name. I guess we can call this our odd row horizontal offset. So odd row horizontal offset. So this is what we need to add to the position each time that we're on an odd row, just so it's shifted across by a little bit. So the way you can think about this is we can check, hey, is it an odd row? If it is an odd row, then we need to add the offset. Otherwise, we don't. Right? So you can write this out in a longer way. I'm going to try and keep this concise. I'm going to use a ternary operator, which is kind of like an if statement in one line. So we're going to say, hey, is this an odd row? If it is an odd row, then the value we're assigning to xpos is going to be equal to our this. But we also want to add to it that new value we added, right? Which was called odd row horizontal offset. However, if it's not an odd row, then we just want this bit. We just want the standard. Okay, so that should give us our rules for offsetting it every second row. So now that we've got that, we want to go on and spawn a class as well. So we're going to have to, if we want to spawn a class in Unreal, you need to know what kind of what class you're spawning. And we're going to want to spawn one of our blueprint classes that we've made. You know, the grass hex tile that we made earlier and the water one. Now we can't refer to those in code because we made them in blueprint. So we're going to do the t subclass of so that we can set that as a member variable, and then it'll look in that variable and spawn whatever you've set up there. So we're going to go ahead and create ourselves a t subclass of hex tile, which will allow us to set the tile that we want to spawn in. So again, it's going to be another U property. Probably this isn't layout based, this is more setup based. So let's give it a more meaningful category here. And then it's just going to be a t subclass of, and then a hex tile is the base class of those blueprints that we've made. And I'm going to go ahead and call this grass hex tile, for example. Okay, a couple of things that we should think about. We probably want to forward declare what an a hex tile is in here. So let's go ahead and do that, because we're using another class in this header. So you can just go ahead and do that. And then we'll fully include it in the CPP file when we use it. Okay, so now that we've got that, we can start going through our spawn logic. So let's go ahead and do that. So for now, I'm just going to go t subclass of. I'm going to store it as a local variable for now. It may look a bit redundant, but we'll come back to add something later where it'll make a little bit more sense. So we're just going to call this tile to spawn. And for now, we're just going to simply assign it to grass hex tile. Now, the nice thing about this is, like, this is just a very basic implementation. You could do whatever logic you want here to choose what type of tile to spawn. So that's why I've got like a member for it. So you can play around and experiment and think how you want to spawn different tiles if you want. But we're just going to spawn the grass one for now. And then we're going to go ahead and actually spawn it. So we're going to make a new tile. And we're going to do the normal code that we need to do for spawning a tile. So we want to spawn an actor. That actor is going to be of a hex tile type. And then the arguments, we need to give it that asset, so it knows what type of class to spawn. And then we're going to give it a position. So we're going to make an f vector. Now, just making an f int point. An f int point is quite a nice little, it's just a wrapper for like a two values. So I'm just going to go ahead and give this a xpos and a ypos in here that I made earlier. So that's saying where to spawn it, right? Based on these values that we calculated here. And then we want to do a f rotator. And we're just going to do a 0 rotator. We don't need to rotate it on a particular angle that we know of at the moment, at least, right? So that should spawn it in for us. And then, so I think it might be a good idea for us to probably add give each tile an index as well. So, you know, these f int points that I talked about is like a little wrapper to say, here's an x and a y value in one member, right? So let's jump to this a hex tile and add one of those in. I think that'd be a good idea. So let's make this public so that we can access it as well. You could make a setter and getter for it if you want, but I'm just going to be keep it simple for now. So I'm going to make this visible instance only, so that we're just going to use this just to show how it's working, right? So this is going to be visible instance only. That should be fine. Actually, I don't think we need to do more than that. We could give it a category still, which is going to be equal to tile, like the rest of them. Okay, and this is going to be an f_int point tile index. So that's just the index that it is. If it's in the top left corner, it'll be 0, 0, and then it'll be 1, 0, 2, 0, 3, 0, and then next line it'll be 1, 0, 1, 1, 1, 2, etc. So this is just representing where it is in that two-dimensional grid representation. Okay, so now that we've got that, we can access it. We should set it, because we know at this point, while we're making it, we've got the x and the y that we're iterating over, right? That is effectively the coordinates in this 2D grid. So we're going to store it while we've got it now, because that'll be very useful for us later if we want to refer to a specific tile, not by what actor it is, but by its tile index. And that will really play into how we access our 2D array, where we give it an x and a y kind of index in order to access something in our grid. So, okay, let's do that. So our new tile, we want to go ahead and set the tile index to be equal to what we just set up a sec ago, right? Which is going to be an f_int point again, which is going to be our x pos and our y pos. Okay, so actually no, not the pos. My mistake. That would be a float. We don't want to do that. We want to just do our x and our y. We want this to be 0, 0, 0, 1, etc. So x and y. Excellent. Okay, cool. So now that we've done that, the last thing to do is to assign it. We've spawned the array. We now want to store that in our 2D array, right? So we're going to go Hex Grid 2D array, and then we can access it via this nice system that I mentioned earlier. We can now go x, y, and on this first loop is going to be 0, 0. So the very first top left corner one, we're going to store new tile in that position in our 2D array. Nice. So this is the basics that we need here. So we work out if we're on an odd row or not. We work out the x position based on where we are looping over our grid height and our grid width, which is our y and our x respectively. And then we choose what type of tile we want to spawn, and then we spawn it. And then we store in our 2D array that tile. Excellent. Okay, so that should be sorted. We may need to do some includes now. So I'm going to right click and include my hex tile that I made, and that'll add it up to the top here. I don't think we're using anything else that isn't part of the kind of base code, like inpointer and rotator, and that we don't need to include those. So let's see if that works then for us. We'll do a hot reload and we'll see what happens. Hopefully we'll get the happy noise. There we go. Right. So now that that has been set up, let's go and have a look at what we've got. We go into our blueprints. We need to create one for that Hex Grid Manager that we've made now, right? So let's go ahead, make a new blueprint class. This is going to be from our Grid Manager that we've just been setting up. We're going to call this BP Grid Manager or Hex Grid Manager. All right, great. And this is going to be like kind of an empty actor when we add it into the world. So if I add it in, we'll check it as 0, 0. Okay, so it's an empty actor. If I'm not clicking on it, we have this view here, but we're not going to see anything in game to represent it other than the tiles that it's spawning. But we haven't set it up yet. If you remember, we did go ahead and create a bunch of members for it, right? We need to set up these values, and we didn't set any defaults for it, so we're going to just set them up in editor now. So let's go ahead and do that. So let's go into the blueprint. And here we go. We've got our hex grid, we've got our layout, and we've got our setup. So first off, we're going to set our asset. If you remember, this is the tiles that we want to spawn in. It's a T subclass of hex tiles. So we're going to just point it towards our grass tile. Okay, just so that it knows what is the asset to use for grass tiles. And then we can think about the maths again. So if you remember, our grid width and our grid height is how many tiles in each direction do you want to go. So let's do our width is 5 and let's do our height is 4, for example, right? So 5 across 4 down. Now we need to put in our offsets. And I know we've looked at this a few times before, but just to remind ourselves, so each tile across was that funky number that we looked at through doing the square root of 3 times in by the size of our hex thing, right? So let's go in and set this now. So we've got the calculator still open. This was the, let's just do it again. Square root of 3, oops, wrong button, excuse me. So 3, like that, times by 100. Okay, cool. Let's copy that in here. And then we have an odd row horizontal offset. If we remember, that was how far across does it need to be shifted on the second row. And if we remember, that was half of that value. So we can now go times this value by 0.5 to half it. Cool. Now we can copy that. So we'll chuck that in as our how much to shift it across. There we go. And then our vertical offset, if you remember, was 75% of the height, which was 150. Okay, so these values should roughly work for us, and we're going to tweak them a little bit, just because I think we're getting some rounding errors probably. You can see how it's stopped early here. So it's not going to be perfectly accurate, but we can add little values to it, and it should be fine. Okay, so that is the setup that we needed to do. Shall we have a look what happens? So we're in the middle of our map over here. Oh, one thing I'd want to do actually is, just as a good practice, is when you're adding in these actors that don't have a physical representation, it's quite good. You can add just like a billboard component maybe in, just so it's easy to click on this thing and to see it in editor. So let's just move this up into the air a little bit. That should be fine. So now what we should see is there's a little dinosaur head here. Yeah, just so we can see it easy. Because you might have a few things that have this little white placeholder circle thing there. So, okay, so there it is. We're clicked on it, and we can see now if we want to tweak those values more, we can do them down here. But let's see what it looks like when we press play. Okay, so this is the direction that we're facing. Let's make that. Let's fix that now. Actually, so you'll notice that my player start by default is facing in the X direction, whereas if we're looking down at this map, we kind of want to be looking so the Y axis is in front of us. So I'm just gonna do two things. One thing actually. I just need to rotate this player start. So I'm just gonna press E to go into the rotate mode, and then we're gonna rotate it 90 degrees so that it's facing, it's going along the Y axis now instead. There we go. So now when we press play, I should be able to just look down, and we're on that top tile, and this is our grid. You'll notice it is, if I press F8 to jump out, this is our grid. We've got 5 across, and we've got 4 down, just like we said we wanted, right? And what you can notice is, remember I exposed this out to be visible only. You can see the coordinate system in place. So this is 0, 0. This is 1, 0. This is 2, 0, 3, 0, etc. And right at the bottom, we're going to have our 4, 3. Remember, 0 indexed like arrays are, right? So there is 5 across and 4 down, because the 0 index, it'll max at 4 and 3 respectively. Okay, so that kind of works for us, right? And if we go into our top-down perspective thing, we can have a look and see how the gaps look. And you do get these tiny little slivers, and this is what I was on about earlier, that, well, there's two things to think about here. One, you might want to visually make it look a bit separate so they look more like tiles. And two, we have the potential rounding issues as well. So let's go ahead and tweak some of these values, shall we? Like, if you want, you can always come into this view and just kind of move things around and see, you know, if you change this down to 1, for example, you can move it around to kind of see, well, I want it to be like that much of a gap, and work out how much you've moved it. But I'm just going to go ahead and just tweak some of the values we have. And this is why I wanted it to be edit anywhere. So I'll click on my manager, and we've got these values before, right? So let's just go ahead and add some values. I'm going to kind of simplify these values. Actually, no. We can just add an offset to it. So I'll add 5 to that. I'm going to add 5 to my vertical one, and then the odd row offset. If you remember, that's like half the distance across. So I'm just going to add 0.25, which is half of 5 to that. So that should give us. Oh, hang on. Not 0.25. 2.5. I wanted to do. My mistake there. Okay. So now what we should get, if we look down, is we get a little bit of a gap between them. So that might look a little bit healthier when you're looking at your tiles on an angle. You can see them all as tiles now, for example. Now, we're not going to talk about it, go into detail now. This is something for a future video or whatever. But if we're spawning in a lot of actors like this, you do want to be a bit considerate of things like casting shadows. You wouldn't want like 100 of these tiles all to be casting shadows. So you can go into the meshes. You can turn off things like casting shadows. You could even use mesh instancing to kind of increase performance with this stuff. But that's beyond the scope of today's video, so we're not going to properly go into that. But hopefully now you can see that we can change these values. So if I now want like a 7x7 grid, I can go in and press play, and I've got myself a 7x7 grid this time, which happens to be overlapping with the set that we set over here. So let's move that so it's a little less confusing for us. There we go. So that's handy. We can now see all of our tiles, and it's given us exactly what we set up. And we can tweak that easily now without having to do the maths or move things around manually each time. So that's positive. Now, we're going to do a couple of things just to help you debug if you want to take this further then. So at the moment, I showed you that if we press F8 to kind of jump out of our pawn, we can then click on the different items, the actors here, and we can see that they're tile index down here, right? Let's go ahead and try and display this instead, just so you don't have to jump out and click on them each time. So there's two steps to this. First, we're going to just record that the information about the tile index somewhere, and then we're going to make the tiles show that to us. So first things first, let's go ahead and go into the bit where we're setting up the tile. And what we're going to do in here is we're just going to do something called setting the actor label. So by here should be fine. If we go to new tile, and we're going to go set actor label. This is something that you can basically use for debugging, the set actor label is. And we're going to go ahead and make a string, and we're going to just concatenate some stuff together. So bear with me while I write this out, and then it'll make a bit more sense to you. So we want to give it a name of tile, and then we're going to give it the X and the Y coordinates afterwards. So I'm doing the %D, because they're basically going to get replaced by what we put next, which is going to be our X and our Y. So what this is saying is for each tile as we spawn it, give it a actor label of tile 00, tile 10, and the likes. Okay, so that's what we need from a code side. So let's go ahead and compile that, and then we'll go into our base tile. Remember I said that's the idea of having a base tile is now I don't have to go into each of these tiles and change the code. I can just do it in the base one. And we need to do a little bit of blueprint logic. This isn't great for performance, especially here, but we're going to go ahead and we can just tell it to print off or to display that. So I think there should be a print. Oh no, sorry, debug string, I think. Draw debug string. I think that's the one there. Yeah. So we can do that on tick for now, just for example. Where do we want to spawn it? We want to get the actor location, so it spawns on the tile itself. So get actor location will give us where we want to spawn it, and then the value we want to give it is going to be based on this actor, right? So is it get display name? I think it is display or actor label. Yeah, that should do it. Okay, I need to get a reference to this as well. So let me get a reference to myself. And then we want to get the display name, and then we can just whack that into the text there. So hopefully if we compile and save that, what that should give us now is when we play this, there we go. We've got our index written out on top of the tiles. It's a little bit messy, but it gives you an idea. It helps you work out if you're going to move on to look at how to do, you might want to put units on this tile and move them. And you want to give them a tile to move to, or you're trying to work out the neighbors around each tile, it'll give you a better debug kind of visualization to help you with that. And I would want to say on that point, if you are looking to extend it, I might do another video, but if not, use this system. There's plenty of information about how to work out. You can look up like neighbors in here, and it has a whole section on like how to work out the neighbors of in a hex-based grid system. So it's a really, really useful resource that I pointed out to you right at the start. Okay, so we're at a point now where we've got some decent debug info. The final thing I'll do, since we made a water tile, let's add in a water tile so you can start to see how you could build up on this instead of just having this, that you can make it look a little bit more varied and have different tiles in it. And we're going to do it very simple. I'll let it be on you to kind of come up with clever ways to do it. For example, with my game, I ended up using like a 2D texture that you could paint different colors on, and then it would spawn a different tile based on that. You might want to do some random, an algorithm which chooses tiles randomly based on certain conditions or neighboring tiles. It's completely up to you, but we're just going to keep it super simple for now. We're going to go ahead and we're going to just do a little bit of logic to say, hey, sometimes spawn a water tile. So we can just say, hey, we need a water tile first off, right? We got this grass hex tile. We're going to make a reference to an asset which is going to represent our water hex tile. So water hex tile. So let's save that. We'll have to set this up in editor as well, but we'll assume that we'll remember to do that. So if let's just do we're just doing a little rolling of the dice here basically. So we do a random range of floats between 0 and 1, and if that is greater than, you could put in, you might want to expose like a water chance. So let's do, like, just for now, let's do chance of water, shall we? Like that. So if it's more than, if you say that it's hang on, let me just make sure I'm putting the right value, 25% chance of water. If it's more than it, yeah, so this would be less than it, I guess, would be more accurate. That way, if we put like 0.25 as our chance of water, that means when you roll it, you've got 25% chance of the water spawning. Yeah, that's more correct. Less than or equal, you might want to do as well. But... okay, so if our random roll is under the amount of water chance that we set up, then we want to just change the tile to spawn to be equal to our water hex tile instead. So it'll spawn a water tile in that environment. Very simple. We're not doing anything complicated here, but it's just to give an idea and give a starting point for people to start working on their own hex ideas then. So this chance of water, we're just going to expose out as a float value as well. We'll just borrow this for now. This can go into our setup. And this can be our chance of water. Okay. So, if we do a new hot reload now, we should hopefully get a chance of water variable that we can change. And if we remember to set our water tile in our manager, so we should do this on the blueprint of it. So let's go into edit blueprint of this. Where is the bit where we go to the hex here? Can you see our hex water tile? We want to go ahead and set up our water tile there. We've got a chance of water. We can leave that as 0 for now, and that should mean that we don't get any water unless our random, yeah, this should all be green. That's great. Yeah, and then if we click on our grid manager and we say, okay, now we actually want to change this. We want a 50% chance of water. Now let's do a little less. Let's do 25% chance of water. Now we press play, we can see that we're getting water sometimes as well. And that'll be different every time now because we're randomizing it, right? So the layout of water looks different. And if we want to go ahead and make it mostly water, we can go ahead and do that. Give it 90% chance, 0.9 in there. And there we go. We've got tiny little bits of land instead. Little islands, perhaps, and you could sail around. It's up to you what you want to do with these sort of games. That's why I'm trying to leave this quite bare bones to allow people to kind of build on top of it however they want. But yeah, that hopefully covers everything that I wanted to do now, that you now have a way to go ahead and set up a simple tile. And then we have done logic in the CPP so that we can read the height and the width, and then we'll loop over those and we will spawn a tile asset and we'll position it correctly based on the hex tile kind of system that you're going with. And a final reminder that I do recommend using this web page that I've been showing you throughout, because it is super helpful and it allows you, if you don't want to do it in the exact same setup as I did, if you remember, mine was pointy, like the pointy side up, and then it shifts into the right on the second row. If you want to do it a different way with the flat side up on the top of it, and you maybe want it to shift to the left on every odd row instead, there's different maths and calculations that are explained on this page for you. So hopefully that'll be useful for you. But yeah, if you enjoyed the video, feel free to let me know. If you want more about this, so I can show you more things you can do, like how can you work out the neighbors, how can you add on units onto the grid and move them around, how can you have a camera that you can pan around, for example. I'm happy to do more content, but for now, I hope you've enjoyed. I hope you've learned something. I've been Dan. You've been great, and I'll see you again soon. Cheerio.